Welcome friends. In this video, I'm gonna install PGVector. I'm gonna do some embedding and then I'll do some retrieval augmented generation. Let's go take a look. I made some more SpringAI AI art. I thought that was kind of fun. Okay, so my overview, like I said, we're gonna set up PGVector as our vector store. Then we're gonna embed into it. We're gonna embed specifically the SpringAI documentation. And then we'll do some retrieval augmented generation where I'm going to ask Llama basically to tell me about the SpringAI things, and it will be able to tell me because it has access to those docs through the embedding. Okay, let's go do this. Some notes about AI embedding and RAG. So why are we doing this? In order to answer about data that the model is not trained on, right? I'm using Llama 3.2 and Llama 3.2 does not know about SpringAI. So what do? I vectorize the data, specifically just the documentation, right, grabbed from the website, and embed it into a vector store, right? Embedding stores data along with a relations vector, right? That's a vector is a big list of numbers. And so for each of the parameters, it shows how much the current text that I am embedding is related to a certain term. And so it knows how to connect it to the rest of the data that it already knows about. Then when a query comes in, the vector store is queried for related data, right? Basically, it looks at the request I'm making and it makes a relatedness query to what's already in the database to create a context. So related data is added to the prompt as context along with instructions to base the answer on only that context, right? That's retrieval augmented generation. Now, the embedding model that we're going to use is used both for doing the embedding, putting it into the database, and also for retrieval, taking it out of the database when it comes down to this related data. So we'll see both of that. So a note about this code, SpringAI is still very new. It only just hit 1.0.0. And during the process of building this, I encountered a variety of bugs. I also saw a bunch of features that are coming down the pipeline, which will be very useful. They were there already in the documentation, but not yet in the Maven repositories. So things are going to be improving in the near future, definitely. I was able to make everything work, but things may change in the near future, right? You might do things slightly differently from what you see here if you're watching this in the future. Okay, so my setup. I used Llama running locally. The model for embedding is Nomic Embed Text. I chose it because it was the most popular one at the moment on Llama. And the model for chat was Llama 3.2, which I showed in my previous video as well. For the vector store, I'm using PGVector, which is really just PostgreSQL with a vector extension. And I'll show you how to set that up. So first of all, setting up PGVector. Now, the easiest way to get the PGVector extension under Windows is through Anaconda. Your options really are either compile it yourself, do a Docker container, or install it through Anaconda. Right now, what is Anaconda? It is a cross-platform package manager, right? So it runs under Windows, Mac OS, and Linux for AI-related tools. Sounds good, right? It was originally focused on Python AI tools, but it branched out to tools of any language. So that's why we now have PGVector there as well. It is free for students, but requires a paid subscription for companies. This is the website where you can download it. Let's go there. I'm going to go to, I have it open here. Let's go to the front page first, anaconda.com. And then we can just click on free download. They do want you to sign up for their newsletter, right? To give them your email address. You can do that because you can always unsubscribe again as well. So that's the only sort of downside. Nevertheless, the download is pretty pain-free once you've signed up. And then you can just run what you download after it has installed. If you're under Mac OS or Linux and are using C shell, the Z shell. I believe it's the default now under Mac OS. and it was definitely, I configured my Linux to use it, so I definitely had to do it. You have to run this one extra command, conda init C shell, because it needs to put itself into your shell environment. And it needs to know which shell that is. Let's go to, I'm going to go over here. I'll show you what it did, and then I'll have it do it again. So in my C shell RC, oh, I'm in the wrong place. You can see it here, right? This is the environment that it adds. And if I were to remove it, I can make it come back with this command, right? Conda init C shell. Right, it basically checks that everything's set up, and it sees that my C shell RC did not have it. Right, and so it puts it back in over here. Okay, so that's a note. If you're installing under macOS or Linux, be sure to do conda init C shell to have it added to your shell. And then after you've done the init thing, close your terminal and open it again to make sure that the environment is completely integrated as well. All right, so Anaconda. Now that we have Anaconda set up, what we need is an Anaconda environment. Anaconda is a tool that allows you to make multiple environments, right, from the command line, and that's so that you can easily have slightly different test environments. But for us, we just need one, so that's what we're going to do. We're going to say conda create -n my-env, right? Very straightforward. Conda create -n my-env. Do we want to proceed? Yes, just put it right there. That's fine. And then we want to say conda activate my-env. Good. So now that we've created and activated a environment, because it needs always at least one, we can start install packages into it. So what are we going to install? We're going to install Postgres and that extension to Postgres, PGVector. So we're going to do, let's do clear here for a moment. Conda install conda forge PostgreSQL. There we go. It's going to download it here for a moment and install it. Luckily, it's not very big. Yes, do you want those things? Go ahead. And then we want to say conda install conda forge PGVector. So install that vector extension into Postgres. Good. Then we're going to set up Postgres where we want the database files. So I don't want the database files here in my home directory, so I'm going to say cd code SpringAI, and then I'm going to say init. Just let me check if I don't still have it lying around. DB files. I'm going to remove these DB files from my previous tests. So I'm going to say init db -d db files. Right, so it creates a directory for database files. Takes a moment. It wants to sync it to the disk. Then we can start Postgres with this command. I'll just copy paste that here for a moment. Yes. And so now we have started the Postgres server. Ooh, we want to create a database inside of it as well. Still create DB embeddings. So let's do that as well. Create DB embeddings. And then we want to create a user. I'm going to create a Postgres user that my application is going to be able to use. I also want to have it prompt for a database, a password, so that I'll make both a user and a password. So create user Postgres. I'm going to be very creative here and make the password also be Postgres. Not very secure, but this is just a little demo. Oh, mismatch. Postgres. Postgres. There we go. And then we're going to say psql -d embeddings. This is going to start the psql command line. We want to connect to the database called embeddings, right? We just made it a little earlier. Create db embeddings there. And so now we're on the command line. Let's go here to the next slide. And we need to first activate these extensions. So we're going to create the extension a vector. We don't actually have to say if not exists because, you know, it's an empty database. I'm sure it doesn't. and then HStore, and then UUID OSSP. So I'm going to say create extension vector, create extension HStore, create extension UUID OSSP. Okay, so we've created the extensions. Now we need to create the table. This is the table that SpringAI expects. So let's do that. So I say create table. Again, we don't have to say if not exists. It doesn't hurt, but we don't need to because we know it's empty. So vector store open parentheses. Then we want for the ID column, it has to be UUID default UUID generate v4. V4 is going to be our primary key. No typos. Okay. Then we want a column for the content, which is going to be of type text. Remember, we're going to take text, in our case, from a website, and we're going to put that into the database along with our vector of relationships. So content text. We're also going to provide it with metadata in form of JSON, saying, you know, where we got the text from, when we got the text, what data set we want this to be part of, all those kinds of things. So metadata, JSON, and then embedding a vector. The model that we use wants an embedding vector of size 768. 1536 is the default embedding dimension, but nomadic embed text wants 768. It's fine. And I think that's also the end for our table. Yeah. Okay. Then we want to create an index. Create index on a vector store using HNSW. Embedding vector cosine ox. That's our index. Then we also want to grant access, grant all on a vector store to Postgres. Remember, we just made that Postgres user that our application will use to log in. And so we want it to have access to this table. Good. Then we can press Ctrl D or /Q to get out. And so we set up Postgres vector, and we're ready to do some embedding. Okay, let's take a look. So embed the SpringAI docs. That's what I want. So Llama 3.2 has no in-depth knowledge of it. If I just run it and ask about SpringAI, it sometimes hallucinates some things, but we really want it to be able to say, yes, you know, hey, I want to be able to ask about a class and ask it like what kind of methods are on this class. And I want it to be able to give me a good answer. So in order to do that, we're going to do some embedding. So we're doing this with Nomic embed text. And currently, the reason I chose it is it's the most popular open embedding model. Let's look at the Llama website. We'll see that as well, right? Llama. So if I go to models, and I say embedding, then here in popular, right at the top, Nomic embed text. So that's why I'm doing it. 21.3 million pools. Okay. So that's why I took it. And in order to install it, we do Llama pool Nomic embed text, right? I already did that. I think I can say Llama. You see it in my command line history here. And if I say Llama list, we see that it is installed. Right. It's also not very big, 274 megabytes. Pretty okay, not a problem. All right, so we installed it. Then our Spring Boot application is going to use SpringAI Llama, right? The Spring Boot starter. SpringAI PGVector, right? That's the vector store we just set up. And I'm also using JSoup for our crawler, right? Because I'm going to go on the internet, which is going to give me HTML, and I need to just turn that HTML into straight up text. So JSoup is going to help me with all of that. Connecting to the website, taking the data off, turning it into text. That's what JSoup is going to be able to do for me, because basically I'm going to make a little crawler. So I start on one page and it crawls through all the other pages of the website. So here are my application properties. What we need is enabling embedding, embedding enabled true, embedding options, model, right, nomic embed text. Then for the vector store, SpringAI vector store, PGVector, index type, distance type, cosine distance, and a dimension, right, 768. Then our data source, the URL, the username, the password, and our driver class name, right? All pretty straightforward, really. Our Spring Boot application is just literally the default. I'm not doing anything here, right? Just your straight up default Spring Boot. Then here's where it gets interesting. I made a component. Let's go look at it over here. So I call this not in the Llama RAG. Let's close all this. In my embedding, in the embedding runner. So I made a component, right? I'm not going to run this from the web. I'm going to run it as a command line runner. Right, so when I start up the application, it starts doing it right away. I have the vector store injected. Again, I didn't need to configure anything for the vector store, nothing here, right? Just purely in the application properties, right? That's where the vector store gets made. So then I crawl the pages. How did I make this web crawler? I asked Grok to make it for me, right? And then I did modify it a whole bunch, but okay, right? So I want to crawl docs.spring.io. I want to make sure that the URL always contains SpringAI reference. I want it to not contain either a pound mark right at the end of the URL, because otherwise I get duplicates. And I want it to not contain the number 1.0 in the URL either, because again, that will make duplicates, right? I found that out by running it and going like, oh, I don't want that. It's making duplicates. Then the max pages is 150. I set that after I found out it only actually has about 111 pages in the documentation, so that's fine. It's just a little extra safeguard. And a delay between requests. That's a nice thing as well. Crawlers are considered kind of rude by some people. You know, don't hit my web server all the time or so quick in succession. So I have a 100 millisecond timeout. I think Grok recommended a 500 millisecond timeout, but you know, that takes a little while. So I went to a 100 millisecond timeout delay between the requests. So I make the crawler and I tell it, okay, start crawling there. And then once I have all the pages, let's take a look. Let's take a look at our crawler. All right, so the crawler will open the page, mark it as visited in my little, where I keep track of it, get the page, right? Get the body text, make some metadata, right? I keep track of what the site was, what the title of the page was, what the URL was, what the timestamp was. And then I added to my list of pages. Pages is actually a list of SpringAI documents. Right away, I tell it, okay, just make SpringAI documents. And then after I've added it to my list, I get all the ahrefs, right? All the links that it refers to. And then I throw out any links that are, if it contains, string contains, URL contains. If it doesn't contain what I want it to contain, then I don't do that page. If it does contain what I don't want it to have, right? I have multiple reasons why I would not want to crawl it, right? So I go through that it adheres to my not wanting or yes wanting. And I make sure that I stay within the same domain and that I'm not going to a page that I've already looked at, right? So these are just my conditions for crawling over all of the different links. Yeah, so that's my crawler in a nutshell. And so then I get this list of documents. Now these documents often might be too big. Each document has to go down to a set size for embedding. So I end up taking the token text splitter, which is a class in SpringAI, to cut it down so that I have fragments that are of the correct size for embedding, right? So I take the splitter, I just apply it, makes my list of documents bigger. We have a little info when we run it as well, it tells you how many times it splits, but it's fine. And then I just add my list of documents to the vector store. Now, right, that's the actual embedding. This is also where most of the time is spent. Not the inserting in the database, but the making of all the connections, right? Where the AI model basically is running to find out what all the weights need to be and for, right, to make that vector, right, that list of numbers. All right, here the core crawler code, we looked at it a little bit already. Metadata is very important. If you want, you can filter on the metadata when we're doing RAG. I'm not doing that, but I can see how that could be very useful. And like I said, right, running the project takes about half an hour on my old laptop, and most of that time is spent in making those weights, right, on vectorization. All right, I guess I might as well run it so you can see it running as well. What I'm going to do is I'm going to have it only really crawl the front page. I'm not going to have it follow any links. So I'm going to take this out, and then also if I don't comment this out, it will complain about unreachable code. Let me show you that it works. Let's see, where are we? I'm still in the RAG application. Go cd embedding, and we can run it. So I crawled the page, and then yeah, it vectorized it. Just doing one page is not too bad. We saw that the page got split up into 3 chunks. It gets put into this vector store. And so one page is not so bad, 3 chunks, but 111 pages, some of which are like 18 chunks, it takes a while. Anyway, you can see so that it works, right? So let's continue on to Retrieval Augmented Generation. There we go, right? Finally, I'm going to start the demo now. Actually, what I need to do is I'm going to switch the database to my production database, basically. I'm going to have to say conda-deactivate. Start my system Postgres. Ooh, I need to I've got to turn off Postgres here. PG control stop. Okay, then I can do deactivate, and then I can do cd. Okay, now I can start my system Postgres. Good. All right, so this is the Postgres in which I already crawled everything. Then I can start my RAG application. Not embedding, RAG. Start this. Yes, it's running. Okay, and so now I can ask it. Here, what I'm asking is what methods are available on the chat client class. And if I run that, I think I actually am showing the answer here already, and maybe we'll get a slightly different answer. That'd be fun. See, I start running it, and we can see here in the code, we can see the prompt that it's given to Llama. Right? See all this? This is where the prompt has been stuffed. Oh, look at all that stuff. That stuff all came out of PGVector, all related to chat client. Oh, that's a lot of stuffing of the prompt. Right, so here we see it. Context information is below. Right, and so below this line of the dashes, that is all the context that is being pulled from our vector database, from our vector store, being given to our model because it relates to what we just typed. Right, still coming. Yeah, lots of stuff, right, up to here. And then we see how the instructions are given the context, right, that stuff, and no prior knowledge, answer the query. Follow these rules. If the answer is not in the context, just say that you don't know. Avoid statements like based on the context or the provided information. So our query is what methods are available on the chat client class. Again, because I have a very old laptop, this is going to take a little while. So let's continue looking at our slides. So how did I make this application? I am using, of course, Spring Boot Starter Web. I am not using the Llama API. And the reason for that is I couldn't make it work. I had to fall back or I had to change over to the OpenAI API. It's fine, right? Llama supports the OpenAI API. So it's a little weird. I was able to make it work for just doing retrieval augmented generation or just chat memory, or not both at the same time. Whereas when I switched to the OpenAI API, I was able to do both. So bugs still here and there, but it's fine. It's working. That's the important part. Again, we of course need the PGVector store dependency as well, so we can connect to our vector store. So that's my BOM. And then the properties. I have to again use OpenAI, right? OpenAI both for the chat. This is a configuration that we saw last time in the previous video already. Then here we do OpenAI embedding, enable true. Embedding options model is nomic embed text. My base URL is of course just my local host here, because really I am using Llama, right? I don't have to give it an API key because of that. Then this is the same vector store configuration that we saw in the other application properties as well while we were embedding, and the same data source configuration as well. Then what does my application look like? Here in creating of the bean, the chat client bean, I still create the memory, right, which I had in my last video, because I want to have both memory and retrieval augmented generation, right? That's why I had issues, as I said before, if I used only the Llama API. In my previous video, I said I was going to use the question and answer advisor. Well, no, I couldn't make it work. Could not make it work. It's okay, because there's also still the retrieval augmentation advisor, and I most definitely was able to make that work. Right, I use a builder for it, giving it the vector store, a similarity threshold. The default is 0.5. If you do 0.7, I know it doesn't find anything in this case. So 0.7 is too much. I didn't try lowering it. You'd have lesser or results that are not as good. Figured I'll stay with the default for now, but I did try going higher and finding that it wouldn't work. Top K means how many results do you want? I said, okay, give me 5. So it finds the top 5 matches from the vector store. If you reduce it down to 3, its answer is just going to be more simplistic, right? It won't be able to find as much. So 5 is fine, but 5 does give it that sort of that big list of context that we saw earlier, right? So that's our making of the bean. Very important here. You have to tell it the retrieval first and then the chat memory. The other way around, it didn't like it, right? Again, it would just get confused. So in order to make both the memory and the retrieval work, I had to, you see the instructions, right? I had to do it this way. So the order is actually very important. Can I say that you always have to do retrieval first and then memory? No. Maybe with a different model, it might be better the other way around. But for me, I needed to do it this way in order to make it work. Okay. There is no change in the controller. The controller still is exactly the same from when I last showed it to you when I was doing the chat memory. So this is exactly the same. And we saw the prompt being stuffed, right? We looked at that. We saw oh, and it's done. It's done as well. So let's go take a look. What does it say? Let's make this a little bigger. The chat client class provides several methods for building up a prompt and sending it to an AI model. Here's a list of some of the most notable methods. I should have put this, maybe if I did it in Postman. might have gotten a nicer output, right? Because I think it tried to format this, but because I'm here as raw HTML. Anyway, 1, prompt returns a new prompt builder, object that can be used to build up constituent parts of a prompt. Very true. 2, user message. We used that in the last video. Adds user message to prompt. This message will be passed as input to the AI model. 3, system message. Adds a system message to the prompt. This message is generated by the system to guide the conversation. Yep. And 4, build. Returns a chat response object containing the result of the prompt. And then response. Consumer allows you to chain multiple prompts together, processing each response before sending to the next prompt. Right, so that's pretty good, right? It pulled it out of the documentation. All of that's good. So yeah, good work. Made it work. So in summary, we set up PGVector. We saw that. We did some embedding of SpringAI docs. We did some retrieval augmented generation. We see it working. It does take a little while on my old little laptop, but it works. It works. So some closing thoughts. We saw a practical example of embedding and retrieval augmented generation. Very nice, right? You can see how this could be very useful if you're running a big business. Now, some downsides, a lot of the advisors didn't work that well, right? I tried using that question answer advisor. I tried using both memory and retrieval augmentation with the Llama API. Didn't like it, right? Also, if I did memory first and then retrieval, or right, the order was important, right? A lot of the advisors, it didn't work so well. Llama 3.2 would just get confused. Is it Llama's fault or is it the advisor's fault? I don't know, but it definitely didn't work as nicely as I'd hoped. In the end, I got working. That was the important part. And it really made me think maybe I should write my own advisor, right? To be able to put those system messages into place in the way that I think maybe the model will respond best to it. Because I do have to say, being able to read how the prompt was being stuffed, I was getting confused too. If I had to read that, I would be like, what do you mean, man? Anyway, so this prompt stuffing, it's an art. And just mixing a bunch of these advices together can get confusing to anyone, including our models. All right, so maybe write your own. It's not that bad. Next time, I'd like to integrate Llama with VS Code, right? Have it do some code generation like Copilot, right? Make code suggestions locally. And why I want that is to not have my company or any company's code sent to third parties like OpenAI. We all know that OpenAI violated copyright rights, right? They stole everything off the internet. So I can imagine that if you work for some big company, they're like, we're not connecting to Copilot because it will send all our private code out there, right? So it could be very useful for companies that are still a little on the fence, right, about AI. You can say, well, we can run a local model and we can have our local model do little code suggestions. So that's what I want to do next time. All right, that's it for now. See you all next time. If you like this video, remember to like it, subscribe, all of that stuff. All right, bye-bye.